Okay, is the mic on? Yes? Thank you. I don't know your name, but I appreciate that you always nod vigorously because I can never tell if the mic's on or not, so it's very helpful. Okay. Let's see, where are we? So remember that Exam 3 regrade requests closed today. So if you have questions about how your Exam 3 was graded, make sure you go through Gradescope and post the regrade request. You'll notice that I got Lab 11 out to you again this morning, and we'll talk about that in a second. There was a small issue with forecasts. Actually, it was a big issue with forecasts, which I fixed, aside from the fact that I misspelled forecast, because forecast is a weather forecast. The metric is actually forecast. It's an acronym for something. So that's not the issue I fixed, and I'll tell you in a minute what the issue I fixed is. And also, I've got, a bunch of you seem to have forgotten to put your Hawk IDs on, or have misspelled your Hawk IDs, or done a variety of things that you used to do the first week of classes, and you've been pretty good about for the rest of the term. But I did fix those, and I fixed the code that wouldn't load. If you cut and paste, make sure you get the indentation right, and make sure you match your parentheses. A good IDE will help you make sure that your parentheses are balanced. That's the usual cause of these problems. Post your homework 3 questions on Piazza, and remember we have a final exam coming up May 13th, which is like 2 weeks from today, I think. Now, those of you who have SAS accommodations, we're going to do this through the proctoring center as usual on the same day. I've had a few requests for early exams. You know, it's hard to do an early exam in a class that's curved, so I'd rather not do that. If there's any way avoiding an early exam, let's avoid it. I know there's one person on an athletic team who's going to be out of town, and of course that will accommodate. But in any case, if you have some reason that you can't be here the 13th, I surely will be more favorably inclined to satisfying requests made early rather than ones made the day before. So talk to me sooner rather than later. So this is the material we've covered. I sat down and looked. Most of these chapters were assigned at some point or the other. Some we didn't actually assign, but we covered the material. Like I don't think I ever assigned the chapter on tuples, but we did cover tuples. So this is pretty much the material that is covered on the exam. And if you wanted to start reviewing now, this is what I would start doing. I think you'll find as you go back through ThinkPython at the beginning, these things are very straightforward and they're things that you already know. As I look through the books, at the beginning of the semester, I like ThinkPython better. It's just basically a reference book, and I think that's what people need. But as I get to the end of the semester, towards the end of the semester, I more and more appreciate Python for Everyone, which I think has some really nice chapters, especially at the end, not all of which we covered. But the chapter on regular expressions is really nice. They have a chapter on incorporating SQL databases. There's a lot of stuff in there that's actually very nice. So well worth a look. Okay, so let's talk about the lab. So the definition, the specification gave was this one. The question is return something that is true, or return true or false, or return a Boolean, such that it's true if the word that you're given meets this specification for what it means to be one syllable. And the specification had 4 parts in it. Flush any trailing S's and E's, which are sometimes called the silent endings in English. When you in grade school you talked about the silent E. Do they still do that? You must have, right? All right. Even I remember it. Things like the E in noise, which does not cause another syllable. That each syllable starts with a vowel, and that Y is a vowel when it follows a consonant. Otherwise it's a consonant. Or is the first letter, in which case it's a vowel. So if it starts the word, it's the first letter. And every word has at least one syllable. And you count, I think I just got this backwards. And you count VC transitions, so vowel to consonant transitions. Let's look at the problems with this. The two general approaches, I think most of you took the iterative approach. They're not really that different. I think they're both pretty hard, actually. Getting this right is extremely tricky. More to the point, the definition of syllable is a little bit dicey. And if you look at the lab, you'll notice that I didn't add any words that started with Y, because the status of Y as the initial letter is a little bit dicey. There's no simple rule that works for everything. So for example, One of you wrote to me and said, well, able is clearly 2 syllables. It should not return true. And the answer is yes, able is 2 syllables, but what about apps or noise? Right? These have the same, apps and able, vowel, consonant, final E. Here the E is silent, here it's not. And the reason that these things are so difficult in English is because unlike somewhat more homogeneous languages like, for example, Italian, English comes from a lot of different source languages, right? So there's some elements of Romance languages like Latin or the Latin derivatives. There's some Anglo-Saxon in English. There's German in English. All sorts of really weird mishmash of different orthographies and pronunciations. And so English, there's essentially no rules that work for English. So they're really, really messy. And we have to, as computational linguists, if this is what you're interested in, the whole point to this is to come up with rules that work pretty well. And if you have enough rules and enough data, you can make up for the slight imperfection in your approach. So let's go through the iterative solution first. This is the one I came up with. I think it's similar to what many of you had. The first step, I check to see if the word has the final ending S or E, because the first part of our definition was that we would ignore final endings. And what I do is I set up a new word here, which is actually this pattern in my code, but I made it pat here because I had to fit it on the line. This pattern is going to be either one less letter than the word, if word is an SE, dot lower. So I'm going to take the lowercase version of the word, all but the final letter. But if this is false, then I'm just going to lower the word. So this is sort of an inline conditional that lets me decide this is the pattern I'm iterating over. Okay? And then I start my counter at I. And the goal here is that I'm going to scan through the pattern, the word, if you like. I'm going to scan through it one letter at a time in different stages. And each stage, when the stage completes, I go on to the next stage. And at the end of all my stages, if I've managed to exhaust the entire word, in other words, if I ends up being the length of the pattern, well, then I have a successful one-syllable word. So it's kind of a scan and approve. And if I ever get run out of letters in a way, then I'm going to fail. So let's start by consuming any leading consonants. Remember, Y is a vowel unless it's first. Did I get it backwards on the slide? Y is a vowel when it follows a consonant. It's actually a consonant when it's first. Y is a vowel unless first. I messed up the sense in that previous slide. So Y is a vowel unless it's first. So the first thing I'm going to do is I'm going to check if that first letter is a Y. Then I'm going to continue in this while loop. This while loop is constructed to sort of suck in any consonants. So you start at the beginning of the word, you're going to hunt for as many consonants as you can, consuming all your consonants. So Y in the first position only is a consonant. Otherwise, if I is not 0, or if this is not, or if it's not Y, I'm simply going to continue in this loop as long as that I character is one of the consonants. You'll notice that this is elided here just for the slide because I was running off the end here. But the deal here is this is the list of all the consonants, meaning no A, E, I, or U, but also you'll notice excluding Y. And I exclude Y because Y kind of goes back and forth from vowel to consonant. So when I say consonant here, I'm excluding Y. So at the end of this loop, I will have advanced through all of the leading consonants in the word. I can just go, I'm done with those, I can skip. Now, I'm going to consume all the vowels that I can. But remember, Y has special status here. If Y follows a consonant, then it's a vowel. But if Y follows a vowel, it's a consonant. So the only place I can accept the Y as a vowel is in the very first transition character after the consonants. So if there's a Y here, I'm just going to advance by 1, and then I'm going to consume all of the vowels I can. So consume all the consonants, look for a Y and accept it if it's there, Otherwise, consume as many vowels as you can. And then at the end, consume any additional consonants, again, excluding Y. And when you're done with this, if you're at the end of the pattern, then you have a one-syllable word. Otherwise, you don't. So this is at least my solution. It meets the spec. It works pretty well, but we can see that for the word like the one that somebody raised in a note with me, the word able, we would start by consuming no consonants at all. Then I would get to the vowels. I would not have a Y. I would consume the one A. Then I would consume the B and L. And then I would be left short of the end of the pattern. That's if I don't do the silent E. With the silent E, my pattern just becomes ABL. And so I would consume no consonants, consume no Y, consume the A, consume the B and L, and now I'm at the end of the pattern, and it comes out as one syllable. So you can see that the silent E does affect the processing at the end because I've shortened the pattern by the SE. Are there any questions here? Is this sort of what people did? A number of you were pretty close on this. I don't know about the handling of Y. I didn't test Y cases for a reason because I think it's a little tricky. All right? How many of you tried the regular expression route? A couple of you. All right. So it's my preferred solution as well. So here's the... Hello. Man. So here's a regular expression version. Yeah, now it works. It's the same approach. And this is what my pattern looks like. The essential idea here is I want to exhaust the entire pattern, so I'm going to start at the beginning of the word and end at the end of the word. And if the word matches this whole pattern, I'm golden. Now remember, it's just the same idea. I'm going to scan the word and consume the word as I scan the pattern. So the first thing I do is I look for a Y at the beginning of the word. The question mark, which is the modifier to the preceding pattern element Y here, says there can be 0 or 1 Ys. So if there's no Y at the beginning, just skip that. Then I look for anything that is not an A, E, I, O, U, or Y. This is my set of consonants. Any numbers of those, any number of consonants. Then I'm going to look for another optional Y. Now the interpretation of this Y is that it's a consonant, and the interpretation of this Y is that it's a vowel, but it doesn't really matter. It's just a Y. It's the only locations I can have Ys that I'll accept. So optional Y, 0 or more consonants, another optional Y, 0 or more consonants, 0 or more vowels, and then 0 or more consonants, with, excluding Y and a definite consonant, followed by either an S or an E, which is optional. And if it exhausts the whole pattern, I'm done. Now,